It's Algebra 1, Lesson 5.4, fitting a line to data. It says find a linear equation that approximates a set of data points and determine whether it's a positive, negative, or no correlation. We're talking about a real life set of data. That's what we're doing in this lesson, beginning on page 292. We have four definitions to start. The first one is what is a best fitting line? A best fitting line is one that best fits the data points on a scatter plot. So if your points are not linear, if they are not totally in a straight line, it's a line that crosses as close to all of the points at the same time as possible. Obviously, when we graph something like this and we try to draw in a line, all of our lines are going to be a little bit different than each other's, but they ought to relatively be close and where they have very close values, and that's what I'll show you to go along with that. Positive, negative, and no correlation is a very simple concept. If Again, it looks like the line you're going to draw in has a positive slope, the approximated line has a positive slope, it's a positive correlation. If it looks like it's going to be a negative slope, then it's going to be a negative correlation. If when you plot all of the points, there is neither a positive nor a negative, if it looks like the plots or the points are just all over the place, that's considered no correlation, or which says relatively no correlation, when the data points on a scatter plot cannot be approximated by a straight line. You don't draw one in just for the sake of drawing one in. It'll be considered no correlation. So positive, negative, and no correlation. Very simple concept. Example number one is approximating a best fitting line. It says the data in the table shows the height of a burning candle over time. After graphing these data points, draw a line that corresponds to the data. Write an equation of your line. So it says let x represent the time and y represent the height. To begin, plot the points given by the ordered pairs, then sketch a line that appears to best fit the points. So if we plot each one of these at 0, 0, it's 10 centimeters. At half an hour, it's 9.3. At 1 hour, it's 8.1, and so on and so forth. All of those plots pointed, again, notice, are not perfectly in a straight line. They're a little bit off. Okay, there's a lot of reasons why they're a little bit off. The wind could have blown. Think about what's going on with the candle. It's burning at a constant rate, but let's say they had something in the wax that made it burn faster for so many seconds, or slower for so many seconds. That's the reason it's not a perfectly straight line. But that's also the reason why it's very close to being a straight line. Now that the line is there, though, what you can do is you can get its slope and you can get its y-intercept. First off, the last thing we're actually going to do is get the y-intercept. But as you look at the picture right now, you can see what the y-intercept is. You can see where it crosses through that y-axis right there, where its b value is. So b is going to be 10. We'll come back to that in a little bit. But b's value is 10. It says find 2 points that lie on the line. You might choose the points 0, 10, and 3.54. Again, you could pick any two that fall on the line. Use the slope formula. Notice off to the left it says if you choose different points, you might get a different linear model. Be sure to choose points that will give you a line that is close to most of the points. So again, the slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1, using the points here, 0, 10, and 3.54. 10 is y sub 1's value minus y sub 2 value is 4. So 4 minus 10. I read it backwards a second ago. Again, if you go that direction, make sure you go that direction both times. 4 minus 10 over x sub 2, 3.5, minus x sub 1, 0. So 4 minus 10 is going to give us negative 6, and 3.5 minus 0 is 3.5. So negative 6 divided by 3.5. Notice it says decimal approximation. Okay. 3.5 does not go evenly into negative 6. It's approximately negative 1.7. Notice that's what that little wavy looking equal sign is, the one that looks like this. That means about negative 1.7. So that is our m value. Our m is approximately negative 1.7. So just looking back real quick, does that agree with our picture? Does positive versus negative agree with it? Is this a negative slope? We got negative 1.7. This is clearly a slope. This is clearly a ramp going down. So it's negative 1.7. That's our M value. And again, looking at the graph, our B value is 10. So we have B is 10 and M is negative 1.7. We have enough to write an equation. We need M and we need B. Y equals mx plus B. Y equals negative 1.7x plus 10. On the back, let's do this one. It says you're studying a way, or you're studying the way a tadpole, don't copy all of this, just graph it. A tadpole turns into a frog. You collect data to make a table that shows the ages and the lengths of the tails of 8 tadpoles. Draw a line that corresponds closely to the data and write an equation of a line. So we have a lot of stuff to do here. First thing we have to do is we have to graph each one of these points. Graph 514, graph 215, 9, 3, and so on and so forth. Take about 2 minutes to graph them, and then we'll come back in 2 minutes. Try to be neat as you're doing this, but you don't have to be perfect, everybody. Just try to be neat to make it as easy to see as possible. Okay. When I plotted the points, it looks something like this. If you had a sheet of graph paper, you probably went a little bit faster than the rest of us. If you tried to draw a whole bunch of lines, you're probably still drawing them. When we do stuff like this from now on, just try to get close. You don't have to be perfect because the next part is where the important part's going to come in. What you want to do through this is draw yourself a straight line that goes from through those points as close as possible. Now, this is more difficult than it sounds. It's probably easier in this case to start your line at the bottom and work your way up. So let's say, for example, and this is a lot harder than it looks to get it perfect. Let's say, for example, our line went right here. Okay, just like that. I know that. I know the distance here is further than it should be. So my line should probably be rolled a little bit. But again, this is where this gets a little more difficult because you have to try to rotate it. But I want us all on the same page on the next part. And this is what I want to show you. Okay, so let's say the line looks something like that. Again, it doesn't look any better than it did a second ago. But this is what's important. Let's say it crosses through, just for example, It crosses through right here at your y-axis. Let's call that, just for the sake of making this easy, let's say it's crossing through at 0, 16. Okay, 0, 16. And let's say it crosses exactly through this point right here. So that point right there is 6, 9. And this point right here is 0, 16. This one right here. So 0, 16. Now that we have those 2 points identified, 0, 16 and 6, 9, can we find a slope of that line? Can I say 16 minus 9 and 0 minus 6? Sure. 16 minus 9, we know is 7, and 0 minus 6 is negative 6. So then your slope in this case is negative 7 over 6. Again, the example would probably use an estimated decimal value of that. But negative 1 and 1/6 is what that's equivalent to. Negative 1 and 1/6. And I said, just for simplicity's sake, to where we can get all back to the same spot, this is your y-intercept, 0, 16. So your b value then is 16. So therefore, you can write your equation based on that. Y equals mx plus b. Y equals negative 7 over 6x plus 16. That's the best line to go with the data that's given. Negative 7 over 6x plus 16. Does that match what my line says? Is it a negative slope? Is it going downhill? Is it that ramp going down or up? It's going down, right? So a negative slope makes sense. And it looks like it's about 16. It's probably a little bit better than 16, but just for the sake of making it easy again, that's what we'll call it 16. Okay. Example number 2 is real simple. Again, I showed y'all this real fast before we started. Correlation. A is very easy to see. If you drew a straight line through those points as close as you could see that they're going uphill. So that's a positive correlation. B, you can clearly see those dots are going downhill. So positive correlation, negative correlation. Real simple concept. If they don't look like they're going anyway, then you need to know that that's considered no correlation. On the back, the Hernandez family spent 6 hours traveling by car. Just sketch these 2 graphs real quick. They don't have to be perfect. Just sketch one of them with a positive, one of them with a negative correlation. Oh, I said it backwards, negative then positive. It says the 2 graphs show the gallons of gas that remain in the gas tank and the miles driven for each of the 6 hours. Which graph is the amount of gas left, and which graph is the miles driven? Take about a minute to rationalize that out. Okay, the first graph, positive or negative? We can clearly see it's going down. Which is that? What am I going to write over here? Am I going to, in this blank right here, will we write the amount of miles driven or the amount of gas left? Gas or miles? That is gas, because the more they drive, the gas in their tank is going down. So this one is gas. So this one we can clearly see is going uphill. That's a positive correlation. The amount of hours driven, the more miles they drive. So this one will be miles. The second part of this asks what I already said. Describe the correlation of each set of data. And that goes into the explanation here. Why is the first one gas? because as miles or as hours are driven, gas is going down. Why is the second one miles? Because as hours are driven, miles are going up or increasing. Checkpoint says in example 1, suppose the best fitting line passes through points 1, 8.1, and 4, 2.6. Find the equation of this line. You got a question? All right. Okay, the best fitting line passes through these. 2.6 minus 8.1. You're going to go that way. Opposite signs. 11 minus 6 is 5. 7 minus 2 is 5. 5.5. It'll be negative 5.5 over 4 minus 1 is 3. So your slope then is the decimal equivalent to that. That's what you're going to want to use.